let us derive the distance between 2 points. The point P is x1 comma y1 and the point Q x2 comma y2. So, first drop a perpendicular PS on x axis and QT on y axis, and even drop another perpendicular from P on QT. Now, we know very well, if the point P is x1 comma y1 means here S point is nothing but x1 comma 0, this point. So, this x1 is here, from here we got. So, this point is x1 and here this is x2, this T place, this is x2, it is actually x2 comma 0. So, its x coordinate is x2. Similarly, let me join this one here. This is the point, okay, here one point, let me join. This distance we can say, okay, fine. Now, this distance is nothing but, it is a distance of a point from x axis which is nothing but y1, and the distance of a point from the x axis, this one, this full distance, that is QT is y2. Now, what is the distance OS? The distance OS is nothing but x1, this OS distance. And what will be OT? OT is x2. This distance OS is x1 and the whole distance OT is x2. This is OS. Actually, x1 is distance. If I want to mark a point as S, it will be x1 comma 0 and this will be x2 comma 0, and the distance is, this is x1, this is x2. So, what will be the distance ST? Since I marked distance there, I will write this one as only T. Now, ST can be written as this distance ST. ST is OT minus OS. OT minus OS. OT is already we are having as x2 and OS is x1. So, we got ST as x2 minus x1. Now, this is one part. Similarly, let me find out what is this. This one I will mark it as some PM. What will be the distance QM? I want to find out. Already we are having PS as, this is the distance, PS is equals to y1. So, PS is same as MT. So, which implies MT is also y1. Next, QT is y2. QT is y2. I need the distance QM. QM is nothing but QT minus MT. QM is QT minus MT. We are already having QT value which is y2 and MT is y1. Here we got ST value and ST is same as, we can see here, this is ST. ST and PM are same. So, if ST is x2 minus x1, which implies PM is x2 minus x1. Now, let us see why we found PM and QM. I will consider the right angle triangle PMQ. So, the right angle triangle PMQ, we will use Pythagoras theorem. Pythagoras theorem is nothing but, in a right angle triangle, square of the hypotenuse is equal to sum of the squares of other two sides. Here the hypotenuse is PQ, that distance only we are deriving. So, in the triangle PMQ, PQ square is equal to, that is square of the hypotenuse is equal to sum of the squares of other two sides, PM square plus MQ square, PM square plus MQ square. So, already we have found what is PM and what is QM. QM is MQ, same. So, PQ square is, PM square is Pm we need, Pm is x2 minus x1, Pm square is x2 minus x1 whole square plus mq square is y2 minus y1 whole square. So, this is nothing but pq square. Our aim is to find the distance between the points P and Q, where P point is x1 comma y1 and Q is x2 comma y2. So, what will be the distance PQ? PQ is nothing but root over x2 minus x1 whole square plus y2 minus y1 whole square. So, this is the distance between 2 points x1 comma y1 and x2 comma y2 in a plane.